Is it bold enough? Is it clear enough? Or if you want it to be bigger, I can do that. Okay, it's good. All right. Okay, so um so yeah, we are going to look at minimalist syntax today. Of course, with not everything, we just pick some important stuff and then we discuss. I also hope to have maybe 10 to 15 minutes at the end. Hopefully I can end early so that we can just have a general discussion based on what we've discussed so far or any topic that probably you are working on. And you want us to discuss, maybe there is something you're working on and you want people to share opinion about maybe some challenges you're facing with your analysis or something with respect to syntax or even any area, I think. So I believe there are other people here who are also experts. So we can all discuss that challenge with you and hopefully we can find a solution. So we've been looking at traditional syntax from the traditional grammar, the minimalist syntax. We've looked at traditional grammar itself, and we looked at the principal and parameters theory, or before that, we looked at the early stage of transformational generative grammar by Chomsky, and we looked at the phrase structure rules, which was the major highlight of that era. And from there, we looked at the principles and parameters theory and principles that underline basically the language acquisition or the language faculty. And if you remember, the P and P approach was an approach that was motivated towards explanatory adequacy. We have emphasized that many times, that we want to be able to explain as adequate as possible the language faculty, the underlying representation of language and how it works, the nitty-gritties, basically. And we looked at different models that approach has, the binding theory, control, data, bounding, government, urban and locality and the like. So we looked at that and we finished that in the last class. So today we'll start with, or we are going into minimalism, or the minimalist program as you know it, which is the approach that is beyond explanatory adequacy. So basically what we are saying is so far we've been able to explain, language faculty, the phenomena and everything that we see in the language faculty. But now the question we want to ask, or what we want to look at, is how can we even talk about, or how do we analyze language? Is it possible? Let me put it that way. Is it possible to analyze language beyond the language faculty itself, not just constraining the mechanisms or the tools or whatever we are doing, explaining language, not just constraining it to just the language faculty, in a way, saying that the language faculty is just independent of every other cognitive ability. That was what, before the minimalist program, that was what was assumed. But now, Chomsky again, as is his culture, or as his way of life, I'll put it that way, he always improves on whatever he does. So what the motivation for minimalism comes with these two questions from his book on minimalist program in 1995. The first is, what are the general conditions that human language faculty should be expected to satisfy, basically? So what are those conditions that the language faculty should satisfy? And under that question, there is the notion of, the place of the language faculty in the brain itself, right? So, and that is this A. So what conditions are imposed on the language faculty by virtue of, its place within the area of the mind or the brain? So we know that our mind or the brain, it's not only for language alone or speaking, thought is part of it, and we know language is also part of thought, but there are many other things that the brain or the mind is capable of. So we want to see what are the conditions that, that are imposed on language faculty by the fact that it is within this area of the mind. And secondly, the general conditions of conceptual naturalness that are independently possible. So basically, we want to be able to also look at the general conditions that conceptually, in our cognitive system, there are certain, as humans, for example, and this, in a way, distinguish us from, other, should I say, from animals or, whatever. But basically, what are those conditions? What are some inherent conditions, inherent properties of human that we can actually link to the language faculty? So these conditions are not in themselves in the language faculty, or like um they are not an output of the language faculty, but they are just part of our general cognitive ability. And so what Chomsky wanted to do, one of the motivation for minimalism, is we want to be able to, not just say language faculty is just by itself, but these general conditions of the human mind or general capacity, ability of humans, we should be able to link it to the language faculty. You see that now? And that's why we call it beyond explanatory adequacy. Beyond the language faculty itself, we can see certain principles in the mind of I won't use speaker, of a human in his mind, that is that we can link to the phenomenon that we find in the language faculty. And some of them are like simplicity. We know that humans want to make things simple, not just because of the language alone, but by nature we prefer simple things to difficult things, right? That's one. Another condition or principle that you find with humans is economy. So we want to economize. We prefer to be, in quote, economic than to be extravagant or to do other stuffs that are not necessary. Another thing is symmetry. We want to be able to find relationship, like what relate to one another. And this is, again, it's not just specific to, it's not like an idiosyncratic nature of language faculty. No, it is just the idiosyncrasy of a human, right? It's our nature to want to have symmetry, to have things to be symmetric, basically. And also, and another condition is non-redundancy, right? We find this in language faculty, but underlyingly, we know it is just part of the human capacity or the possibilities found in the human mind. Humans, we want to be non-redundant. We want to be as explicit as possible. So that is one area of, like some conditions that are not part of the language faculty, but now we want to relate them to the language faculty to be able to explain the language phenomenon. Another question is, to what extent is the language faculty determined by these conditions that I've mentioned, right? These cognitive abilities of human. To what extent can these conditions be linked, or can they determine what we find in the language faculty without special structure that lies beyond them, basically? So, and that is what we'll be looking at today. So we'll be seeing this basic cognitive ability of humans, relating it to the language faculty. So far, what we've done so far is basically to explain, the language faculty, what is underlying it, and, acquisition and everything. But now we want to go outside the box in a way. So outside the language faculty itself, we want to be able to explain the language faculty by general cognitive ability of humans. So I have a synopsis, like a summary of what the minimalist program does. So remember that the aim of the minimalist program is to explain linguistics phenomenon outside just the language faculty, like I just showed. Let me see the chart. Is there anything there? No. Okay. So just to explain linguistic phenomenon outside the language faculty itself. And Chomsky's motivation has always been to actually deepen the understanding of the operations of the language faculty. And so in order to do this, there are key notions that were present in the GB that were, they had to be sacrificed. For example, the two levels of representation that we've seen in previous classes, that is the deep structure, the surface structure, right? That we've seen, beginning even from the early days of generative transformational generative grammar, the deep structure and the surface structure. So they had to be sacrificed under the minimalist program. So right now we use more of LFPF, even though that was, it became popular during the P&P. Now we still use it. Even though in recent minimalist syntax, people are also trying to delete in a way, like do away with the PF and LF interface of the language faculty. I don't know how possible that would be, but let's see. So, and also there is another notion, the notion of government. If you remember, that was under one of the principles of the P&P approach. So these are some of the notions that had to be sacrificed under minimalism, and new terminologies or notions, again, that are related to the cognitive ability of humans had to be introduced to explain these things, not just having these ones specific to the language faculty, but they are just a general, whatever we see in the minimalist program, they are assumed to be a general, property or capacity of the possibility of the human mind, basically. And again, of course, the theory of phrase structure. Okay. If you can you mute yourself, please, if you know you just joined?
If you can you mute yourself, please?
Okay, so the theory of phrase structure was also largely eliminated, even though we will see that what we have now also has like the underlying motivation for the phrase structure rule itself, but what we know as phrase structure, like the S-bar theory and everything, had to be sacrificed. So what then is left? So phrase structure rules and transformations, or even what we know as the X-bar theory, like we saw, in the previous class, were simplified into merge and move, basically. So now in the minimalist program, we use merge to build our structure, right? So we start from the bottom, and then two objects are merged together. And then when two objects are merged together, it creates a new object. And what I mean by object is not the object in the sense of like object of a verb. No, I'm talking about elements, right? When two elements are merged together, it creates a new element, like a new object, and then you merge again. So like it's recursive. So merge is basically recursive. So you build your structure by adding another object, like adding another element, basically. So merge is basically recursive. And we also build through move, where you move something from where it was first merged to another position. And in fact, the operation move has subsequently been embedded into a type of merge. So now in recent minimalist approach, even move has been subsumed inside merge. And so we have like internal merge and external merge, basically. So external merge is just like the first merge. So when you pick things from the external, like the numeration, for example, we spoke about that in the last class. So you have the numeration where all the words, the elements that you need to build a structure is there. It's just like you can see that like a bus stop kind of, where from the lexicon you put things in the numeration. It's just like and then from enumeration, you begin to build your structure. So external merge is what happens when you go to enumeration and you pick, two objects, and then you merge it together. And then you keep merging by bringing in something from. So external merge basically is like you pick from outside the tree, outside the structure that you are building, and you merge a new object to create another object, basically. That is external merge. Why internal merge is now what we know, it was what we is what we knew as move, right? Like the movement kind of thing. So that's internal merge. So basically with internal merge, is like what you already have in the structure, and then you restructure it. So you pick, for example, an object that is already merged in the complement of a verb, and then you internally merge it into a new position. So that's why you call it internal merge. It's already there in the structure, but because we want to realize certain maybe information structure or something, you move it to a new position. So that is what we call internal merge. So that's those are the two types of merge. So the internal merge is equal to movement, basically. Why external merge was like the original notion of merging new objects together. So another thing with minimalism is that unlike the two levels of representation that we've seen or we saw in the last in the preceding approaches, constraints on structural derivation are now handled by merge, basically. So what we have with merge is that whatever constraint we've seen before with respect to movement, from whatever you have as a deep structure, and then you have a surface structure when you have a movement, we can undo that by merge, basically. That's what that means. So merge can do the trick for us. When it is first merged, nothing has moved. You have your what you would call as the deep structure or something. And then when there is like internal merge around maybe head movement or even WH movement, then you have like the surface structure because you have a restructuring. So merge can still undo what we had before. Lexical items and their interactions are also reduced to features, which we are going to see today. So features were introduced in a way. So what we say is that every category has an inherent feature. So if you have a noun, it believes that it has an N feature. If you have a determiner, it has a D feature. If you have a verb or verb phrase, it has a V feature, inherent feature, and also some other features to be able to, to come together. So in a way, if you remember the phrase structure rules that we discussed earlier, the phrase structure rule, for example, with a verb phrase would say you have your VP, which would have a V and then an NP kind of thing, right? That's like a typical phrase structure rule. But with merge or in minimalism, we use features to actually merge together whatever complement we need. So what you will see in this handout or in this class with minimalism is that you just have your V alone, and then the V it comes with features. And it does that from the numeration. So within the numeration, there's already features on the V. So when the V is coming into the structure, it comes with its inherent V feature, and then what you will see as like an uninterpretable noun feature. What that means is that it's saying I need a noun. So when it's uninterpretable, it means to be fine, I need to, take a noun as my complement. So in a way, we erase or we exclude the phrase structure rule. Now we use features to be able to build our structure. Again, we are going to see that in a moment. So these features drive derivation, generative processes, and they also constrain what can be merged and what cannot be merged, basically. So it means if, for example, a verb does not have a UP, that is a preposition feature, then it cannot merge with it in a way. So you see that its features can both determine what can be merged with the verb and what might not or cannot be merged. Such feature interactions, they also drive movement in interesting ways, as we're going to see. And talking about features, there
And
are
you know what?
different ways. And one of the main way to actually link items like these categories or even, let's say, words together based on the features that they both share is this probe. So we are going to see agreement probe, where the item that searches for a feature is called the probe. So when you have a V, again, I'm using V with a UN, an uninterpretable noun feature, which needs a noun. When it searches, that is probing. So it probes. So basically, the item that has the feature that must be, interpreted is the probe. So for some of you, this might sound abstract, but we are going to see some examples, and it will become. I just want to give you like a summary of some of the things that minimalism motivated, and then goal. So agreement goal is now the item which possesses the required feature, basically. So see probe and goal in the form of let me make it let's bring it home. So see it in the form of husband and wife. So the husband is the probe. I'm a Christian, so the Bible says that he that finds a wife finds a good thing, and if he obtains a favor from the Lord, right? Now, as the husband is a probe. So you search for a wife. You have to find a wife. So you can see the wife as the goal. That is, when you find a woman that you love that has all you need, that is the goal. I hope that helps to bring that home. So the probe is what needs, that item that needs something, and the goal is that item that has what is needed, the required feature, basically. And then we also look at faces. I'm not going to spend too much time on faces because of it's a lot. It's in fact it's like a subfield on its own, but I'm going to talk about it. So we look at faces, and what faces basically means is that, again, remember that we spoke about, we already discussed the fact that our derivation is in, even movement or whatever we derive is in, they are in chunks. So what phases mean is that when we build our derivation, our structure, we build them in phases, and that helped both language acquisition process and even language passing. So you will see why I said that. So we look at phases whereby structure is built in chunks, and we also look at phase edges. All this will be made clear very soon. So let me just continue. So is there any questions so far? I mean, that section was just to summarize some of the mechanism that we use in minimalist program. Any questions so far? If you have any question at any point during the discussion, you can just raise your hand. I will see your hand, or you can put it in the chat. Yeah. So what, again, don't forget where we were coming from. We're coming from the fact that we say in minimalism, we want to be able to analyze language, explain language outside the language faculty itself. So everything that we've seen so far, the terminologies and everything are basically, if you look at like faces, for example, apart living language faculty on its own. Phase, basically, we know that life is in phases. You see what I mean? So life on its own is in phases. So you don't arrive at a place at just at that point. So you go through different phases. For example, we went through nursery, primary, secondary, university, bachelor's, masters, like that. So, and we're applying that to language faculty, basically. Okay, let me see the chart. Yes, I will do that. I will do that. So uninterpretable features, I'm going to do that. I only mentioned that in passing. So I'm going to, yeah, basically, when you say something is uninterpretable, it means it doesn't have um it doesn't have that feature. Like, it doesn't have the semantic content. I mean, not just semantic, because features can be not just semantic alone, and they can be morphological, and we still use uninterpretable, but the earlier notion of uninterpretability of feature was mainly for semantic reason, but subsequently we know that's not just the case. But if you want to have a simple answer to that, it just means when you say something is uninterpretable, it means it doesn't have an interpretation yet. And then when it gets interpreted, oh no, I don't need to put that. Yeah. And then when it gets interpreted, then it becomes interpretable. So when it gets the feature it needs, it becomes interpretable. Sorry about that. I made them. Okay, now it's okay. Oh no, where are we? Yeah. So yeah, I'm going to dwell more on that soon. Okay. All right. So let's look at the implementation of, in the minimalist program, how all these things we've discussed, like when you have your structure, how do we implement, structural derivation? So regardless of the developments in generative approach to language, the gist is that any grammar must include these two things: the lexicon and computational system for human language. Very important. So we've seen different developments, right, in the generative approach of Chomsky, but regardless of all development that we've seen so far, these two underlying, or these two, you can call them compartments, must be in every grammar, like, of a speaker. So the speaker has a lexicon, we discussed that some time ago, and also the computational system for human language. This is basically, what this means is just like the interaction of, like, all derivations that we are going to see, or that we see in language, all this is done in this compartment or the domain of the language faculty. So the lexicon has all the lexical items and functional elements, or what Chomsky calls substantive element. So what this means basically is that in your lexicon, you have so substantive are basic. You can see them as just like the categories, yeah, like nouns, like the verbs, the prepositions, the adverbs, all those. And all of them are represented with features. They all have their features. So if you have a noun, so a noun, is n, of course, but then the feature n itself can be plus or minus depending on which category has the n. So if it is a noun, then we know that the noun is plus n, basically, because inherently it has to be a noun. So a noun is a noun, so it has n feature. But if it is like a verb would have a minus n, right? Because a verb is not a noun. And then vice versa with a verb also. And then there are also features like transitive, plus transitive, minor transitive. So if you have minor transitive, that means you have an intransitive construction, basically. So if it is an intransitive construction, it is minus transitive. And minus human, plus human, all those things basically all are part of the lexicon. And they are composed of features when it comes to minimalism, right? So take note of that. Why the CHL, that is the computational system of human language, are the operations, like I said earlier. So the derivation, how you derive those, your structures. So that is what you do in the domain of the CHL. So you have the different operations, merge, agree, going on there, as well as the operation transfer. When we look at faces, you will see what I mean by transfer. When you build your face to a point, and then you can transfer it to any interface, basically, to the PF, LF interface. So this is how we implement. So we implement structural building based on these two components. So there is no grammar or no structure you want to build without these two components. There is the lexicon that gives you all the the lexical items, and then there is the computational system within the language faculty that derives and brings its different interaction between the different lexical items, and that is done based on features. Okay, let's make that all the abstract stuff that I've just said now. Let's make it concrete. So let's look at merge from a technical point. So in general, any question so far? Like I said, please drop your question on the chat, or you can raise your hand if anything is not clear. So now we want to make it explicit what we've been discussing so far. So in general, look at this structure in one. The bottle of water might have cracked open. If you notice, we have a case where this is just based on because I don't want to can call it laziness or something. So when you know what that means, when you have a triangle, it just shows that this can be open further, right? So what we see in this structure is actually created by merge. So in a whereby crack and open are merged together, and then it gives you a new object. Remember what I said about that? So when you merge two objects or two items, it gives you a new object. And then when you have this new object, you put we only put a dot there. We are going to give it a name soon. And then you merge a new object too. That means you merge have to the created object, and then it gives you another new object. You see that now? So it's recursive. Merge is basically recursive. And then this new object, again, merges with a new lexical item. All these lexical items are coming from the lexicon, but the merging process is done in the domain of the computational, the CHL, basically, right? So the computational system, this one for the human language. That's where all the derivation is carried out. And then this new item that the merging of might and the old category creates. So this new object can now merge again with another object. But you notice that in this case, it's merging with an object that has undergone different merging as well. So look at bottle of water. there is already merging going on within this constituent. Yeah, it is a constituent. Again, that's important. Remember we've looked at constituency test. So when you merge two things, it's believed that the created new object form a constituent. So for example, crack and open is merged, you get a new object, and that forms a constituent basically. And so when we merge bottle of water, or of course, in this case, it has to be of water first, right? You merge of water, it gives you a new object, and then you merge bottle, and then it gives you this object, bottle of water, and then you merge that, and then it gives you a new object. And then you have this all as a constituent, right? Now, this new object that you merged, usually this is assumed that you did this in another space. That's another thing you need to know when you are doing your structure building in the computational space. So you can have different spaces where you build certain chunks and then you bring it, to you merge whatever you built together, and that's what we did here. So we have a space where we merged all these lexical items, and then this new object is now merged with what we've built so far, what we built earlier. And then when you merge these two objects, again, it gives you a new object. So everything we just saw in one is realized via merge. And that has consequences. Because first, you notice that everything we have here it looks binary. Right? It is binary. So you have your tree in a binary structure. There is nothing that is ternary here. Nothing is ternary, because remember, when we talk about binary and ternary, it's based on that level of merge. So this is one level and it's binary, another level is here, and then you have two, a binary structure. Basically, that's one implication. Another implication is that this structure predicts that whatever you are merging, you must merge it at the root. Remember, I said that our structure is built from the bottom up, and the tree in syntax is like inverted, right? So it's not like the normal tree where it opens this way. It's like it opens downward. So, and that's why we call all these positions, these are roots. So when the implication of merge is that whatever you are merging must be merged at the root. That's another prediction that merge makes, and we're going to see how that works, right? Okay, let's make it more explicit. Any question? Do this merge happen simultaneously? It happens step by step, not simultaneously. It's a step by step, like I just showed. So you see that it's a step at a time. So if you say simultaneous, that can it can result in ternary or even more thing going on. But with binary, even though we have like might have cracked open, which we can decide to we can decide to just have different something like this, like what we've seen in the early stage of transformational generative grammar, right? You can have this ternary, or even this is not even ternary. This is I don't know what you call it, maybe 4-nary or 5-nary, whatever, right? But with merged, it is step by step. So you pick one item, another item, and then you merge it. It gives you a new item. That is one step. And then another step says you bring another item, lexical item, you merge it. It gives you another. So that is a step-by-step process, not a simultaneous process. There is what is called simultaneous agree. In case you want to, you are looking for a place where simultaneity is discussed in syntax. There is simultaneous agree where, and what that means is that you can have like two uninterpretable feature or two things that needs to be agreed. Instead of agreeing, a step at a time, they can simultaneously agree with one component at a time. All right. Okay, so let's build. So remember, all this in one, like I said, it's created by merge. Now we want to build. So what I have explained already, we want to build it a step at a time, right? So, and I think this will even answer your question. So it's a step at a time. So look at this. So you merge just, so merge joins two syntactic objects. Look at two. So X and Y, and then it gives you a new object, right? Which is Z. And you can represent that with a tree, or you can represent that with a bracket diagram, or a bracket, like we have in tree. So this again shows that you merge X and Y, and then it produces a new object. And I believe most of us are familiar with this terminology. So the Z this new created object is the mother of X and Y, which are daughters of Z, right? So X and Y are daughters of Z, and they are also sisters to one another. So the relationship between X and Y is that they are both sisters. And the two sisters, their relationship to Z is that they are daughters of Z. And so Z is the root node. This is the root node. Why X and Y, they are both terminal nodes. And what does that mean? Remember, I spoke about root already. So your root, if you let's do the, if you want to do the tree, the normal way tree looks like, right? So you would have, this is to be the root, right? And then these are like the branches. You have one branch, X, another branch, Y. These are like the branches, but in our own structure, we invert this tree. So this is the root. So imagine this as the root, and that's what we have here. So the Z is the root, Y, the X and Y are the terminal. So they are like, terminal means nothing is, they are hierarchically higher than nothing, basically. They are like the lowest point of the derivation process. And merge is also binary, said that already, and that is why 4 and 5 are ungrammatical, because in 4, you see that we have a ternary structure, right? And merge does not allow that. So when you merge two things at a time, at a step at a time, right? So you can't merge three things. And as well, you cannot have this. Now, this is interesting because if you recall, with the X-bar theory, you can actually have a structure like this with X-bar theory, where you have the bar level, in fact. And that is one of the motivation for dropping the S-bar theory, because it's in a way redundant. So with S-bar theory, whether you are going to merge a complement or not, you always project the bar level. So if you want to have an NP, even though the NP does not take any complement like a PP, S-bar theory says you must have a bar level. That's why you call it S-bar. So you have NP, N bar. This host data, they just muted me. I guess that was a mistake. All right. So in the X bar theory, this is how you would this is how you're going to have your structure. Even if you have, like, you can have a VP like at rice. You have your V. This is like the V bar. And this. Sorry, this is where you have the subject. So we are, in a way, we are already juxtaposing X bar theory and best phrase structure, or we have in the minimalist program. So what you have in X bar theory is that you would have, of course, the subject originating from this position and then moves up. That's not our concern. And my concern is this bar level. So even though the verb takes an NP, but the NP has no complement, but you still have to project this guy, the bar level. So it's redundant. And that's what you cannot do with merge in 5. So this structure is fine in the S-bar syntax, but that is not possible in minimalism with merge. And what merge would do, or what merge does, is that if you have like the noun phrase, you don't need to, you're not merging anything, basically. That's what that says. You're not merging. If you have noun phrase, you just have a verb phrase. So you just have your food, whatever here, basically. You don't need to have any bar level because you don't need it. You don't need it. You don't need any. So food has, this NP has no complement. It's just the food, and that is the head. And this head projects its maximal projection. It projects the noun phrase, and that's simple. And that's what minimalism does. You don't need any bar level, right? So whenever you merge, it has to be two objects, and that's why 5 it's not possible. And then it's also important to know that merge does not specify the order, right? You can merge as in 6 or 7, whereby X linearly precedes Y or Y precedes X. Merge doesn't specify the linear order. Of course, there are other constraints that can determine this, but merge itself, it by itself, does not specify or predict the word order or the linear order of the two merged constituents. Yeah, merge, even though we say, I just said that merge does not specify the order, but we know that order is important in language, right? Look at 6 and look at 8. That's why 8A is fine, John slept, but 8B is not fine, slept John. So even though merge does not, is not concerned by the with the word order, the linear order of the two merged items, but we know that language does not work that way. There's still a constraint on the ordering. There's an ordering restriction when you are merging stuffs together. So that is independent of merge, but we know there is a constraint, and that's why you cannot have slept John, but you have John slept. Another thing with merge, which I mentioned already, is that it is recursive, right? And that is what we find in 9. So you merge X and Y, it gives you a new object, Z, and then again you merge W and Z. Basically, when you say Z, it means you are merging the whole constituent that Z forms, right? So you merge W and Z, and then it gives you another new object. So you can see it's recursive, and then you can again merge another thing, maybe A, and when you merge it, it gives you another new object, right? So basically, we see merge being recursive. So this can say, let's say you merge A, and then it gives you a new object B. You can keep on doing like that to build your structure. So merge is recursive. Another property of merge is that it only combines elements at their root. Again, I've said this. So look at 10. So in 10, you have this object, created by merging X and Y. And then you can also have in 11, merging of S and T, creating R. So if you want to merge Z and R, it has to be at the root, which means the root of this whole constituent and this whole constituent is R and Z, right? So when you want to merge both, of course, you have to merge them at the root. And that's why when you merge both at the root, it gives you a new object M. So when you don't merge at the root, you have ungrammaticality, and that's what 13 shows. So look at 13, compare 12 and 13. Now, if you compare 12 and 13, you see that the problem with 13 is that we didn't merge at the root. And how do we, and what do we mean? Now, again, you build X and Y, which gives you Z, S and T, which gives you R. Now you want to merge it. Instead of merging at the root, that is Z and R, to give you an object, you are now merging at the terminal node. This is the terminal node, not a root. Z should be the root. So when you merge, you bring the terminal node and you merge it to R, that is not to the root. So R, yes, R is the root of S and T, but this new object that you're merging is the terminal of another constituent. That is not allowed. So if you want to merge this, it has to be what you have in 12, where you merge both at the root. So Z and R, basically. You see that now. So why we are able to merge, look at 9. Why we are able to merge W to Z, even though W does not have anything below it, is because, it's because of what I just said now. It has no terminal node. It means it is just the root at this point, and then it merges to this root, and then it gives us a new object. But in this case, that's not the case. In this case, you already have X and Y forming a constituent on its own, like in 10, and S and T having another constituent as in what you have in 11. And if you want to merge both, it has to be to the root and not merging, with the terminal node. So that's not possible with merge. And all these have implication, very important. So far, what we've done is that we've used the operation merge to combine two syntactic objects, right? And that creation or that process creates a new object on its own. And this new object is determined by its head, which we're going to see now. So we've been using alphabet, X, Y, Z, R, S, T, and the like. Now we are going to see that when you match two items like S and T, the legitimate question is then what will determine R? What will determine, the root or the maximal projection? And what determines that is the head. So whatever is the head determines the projection. That is not a new thing. It's a common thing. So when you have a verb, you merge a verb with a noun phrase, the head at that point is the verb, and then it determines what you have as maximal projection, which would be like the VP, right? So the VP, it means that the head of that phrase is a V. NP, it means that the head of that phrase is a noun, and so on. So let's continue. Any question at this point before I go to this next section? Any question with merge? Anything you want to know about? Maybe there is a prediction in your mind you want to talk about. Anything about merge? All right. So now let's look at another important notion in minimalism, which is the principle of full interpretation, which means that whenever you have a structure, everything in that structure must be functional. What do I mean? They must play a role. We don't allow redundancy. You don't. So it's just like whenever you go to the market, you buy what you need. Even though many times we do that by we go to the market and we buy what we don't need. So, but with minimalism, one of the core principle is the principle of full interpretation. So in your structure, every item must be interpreted. It must have a function. It must be playing a role. It must not be redundant, basically. So this simply means that there is no superfluous item is allowed or symbol in a sentence. So which means every item in a sentence must have a function it performs. Look at 14 and 14A and B. So why 14A is ungrammatical is because if you say Adam beat the boy yesterday, the man, that's not possible. That's ungrammatical because you have a superfluous element here, which is the man. So the item or the phrase inside the box, inside the bracket, is superfluous. Adam beat the boy yesterday, fine. But if you say the man, it doesn't make sense. It's not playing any role in this sentence. The same with Sam in 14b. Adam traveled to Lagos, Sam. Except if Lagos, you made it a verb, which is not even possible, to Lagos, Sam. I don't know. Maybe we can play on words here. So if you say Adam traveled to Lagos, Sam, maybe he traveled to I say to show Sam like to treat Sam to a Lagos life, kind of. I mean, English people can help us with that, but we know that Lagos here is a preposition to Lagos, so it doesn't go, right? So Adam traveled to Lagos, basically. And so Sam is redundant, it's superfluous, and it is against the principle of full interpretation. Now, I only use items here, but features can also be superfluous, where if there is a feature that is not needed in a derivation, the derivation will crash. And that's why these derivations have crashed, because we have superfluous item in these derivations. So when there is any superfluous element, what happens is that the derivation it crashes because it cannot be interpreted. It crashed. And the idea is that only phonetically interpretable features survive at PF, and only logically interpretable features survive at LF. Now I'm going to explain this based on, someone asked already, so let me use this point to explain. Now, so with the view, with what I just explained about full interpretation, remember what we are saying is that every item in a sentence, and not just lexical item, remember that we spoke about the fact that our lexicon rather, it consists of both substantive and functional elements. So it consists of both the categories and the features, basically. So not just lexical items. So features can also be redundant. So with interpretability, what we are saying is that when you have a feature that is interpreted, that has an interpretation. So a simple way of seeing that is, for example, a verb. So when you have a verb, the verb eats. Where is the back button? It's not there. Okay, let's just use this. So, for example, if you have a verb, eat, now this verb inherently has an interpretable feature, which is a V, right? Because it's a verb. So it has an inherent V feature, and that is interpretable. But it is possible for this verb to also have an uninterpretable feature. Now, uninterpretable feature is represented with U. And if it is a noun we are looking for, then it is UN, basically. Now, what this says is that this verb has an inherent V feature, which is interpretable, basically, and it has a UN, which is uninterpretable feature, which says that I do not, in my semantics, like basic semantics, I do not have, I'm not a noun, basically. I'm not a noun, but I need a noun. That's what this feature says. So I need a noun to have my proper derivation in the sentence. So uninterpretability basically is when a word or an item does not have the semantics of that feature that you're looking for. It needs another item to be able to get that semantic. That's why we call it uninterpretable. So on that item, that is on this verb, noun is not interpreted, but verb is, because verb is the inherent feature. But it still wants, so what this feature still says is that even though inherently I'm not a noun, I need a noun. That's what that means. So I'm not a noun, but I need a noun. But with V, I am a verb, basically, and that is interpretability. So interpretability can be seen in the with the lens of semantics. So interpretation, like meaning, basically. All right. So the distinction between interpretable and interpretable features is at the art of minimalism, as we're going to see, because that's how we build our structure. We actually use that in building our structure. And it's important to note that uninterpretable features are not just unimportant to semantics. If they are present at LF, the semantics is so confused that the derivation crashes. Remember, I said that when I was talking about superfluous, like this, the principle of full interpretation, I said not just lexical categories, but features can also be superfluous. So it means that if we are deriving our structure and there is an uninterpretable feature remaining in that structure, at LF, we can't interpret it, and so there is crash. Because at LF, every feature must be interpreted. There must be interpretability, because LF deals with semantics. So if you have a UN on the V, and when you get to the LF, for example, let's say, let's use intransitive, like Adam slept, right? Now, if you say Adam slept, we know that slept is a one-place predicate, right? And then if you give the verb, that will take us to, okay, let me just explain what I mean. So if you have a verb that has a UN feature, just like eat, and then after building your structure at the end, this UN is still there. By the time you want to get the interpretation at LF, the derivation will crash, because you have to delete this UN, and you delete that by checking, feature checking. We are going to see that in a moment. So you do that by feature checking. So whenever you have an uninterpretable feature, you have to check it, so that when you get to LF, that is the logical interface of your interpretation, it doesn't crash. It has it can go through. That is because you have checked that uninterpretable feature, right? So we are going to build our structure using features. I guess that will again make it more accessible, in case all what I've been saying so far with respect to feature uninterpretable interpretability might be abstract. We are going to see how it works with respect to merge and derivation of our structure. Before we do that, these are two requirements that we must take note of when we build our structure and when we are trying to deal with features. The first is the checking requirement. Remember, I said that every feature or every uninterpretable feature must be checked before it gets to LF. it must be checked, or even PF, if you're dealing with morphology, for example. Before it can be pronounced, it must already be checked. So, and how does that work? That's in 16. There is a checking requirement. It says that uninterpretable features must be checked, and once checked, they can delete. That's a requirement. And that is because, like, again, we cannot take uninterpretable feature to LF. So we have to check them. So there's a requirement for them to be checked. And this checking has to occur under what we call sisterhood condition. There is a checking under sister. And what that means is that an uninterpretable C selectional feature, that is F, on a syntactic object Y is checked when Y is sister to another syntactic object Z which bears a matching feature F. Don't worry about all this composition or whatever it, how abstract it might be or even difficult. I'm going to explain what that means. What that means is that when you have, look at 18, let's use 18 and 19. It means that when you have an uninterpretable feature F, which is this now. F is just, again, we're using as a generic item. It can be UN, UP, for example, like in 20, right? You can see that in 20, you have it as UN, but I'll get to that. Let me explain this notion of sisterhood, checking on that sisterhood first. So what feature does, or what happens is that for you to check, so if you have a UF, that is an uninterpretable feature that must be checked, when it is on Y, it can only be checked when Y, or when the element that has that feature is a sister to the element that carries the feature, the uninterpretable feature. What does that mean? Again, it means when you have a UF and this UF is on the Y, this UF on Y can only be checked when the interpretable feature is on the sister of Y. So Y has the feature, the UF feature, YZ has the F feature. F means it is interpretable, basically. So UF, uninterpretable feature, F, interpretable. So you do the checking based on sisterhood. And C command also plays a role. We're going to see that. But let's take it a step at a time. So sisterhood. So, and 18 would therefore result in 19. So what happened is that in 19, now we have checked it. So UF has been checked. And when you check an uninterpretable feature, you do that by doing a strike through. And that's what we have in 19, right? So Y has a UF feature, and then the sister of Y has an F feature, that is, it has an interpretable feature. And so because both are sisters, the F feature that is on Z can now check the UF on Y. That is checking on that sisterhood. And so this accomplishes, the checking requirement, because now UF has been checked. Now we can apply this easily to English. Let's see in 20. So if you have a VP as in Kiss Pigs, let's say Adam Kiss Pigs, or but let's just look at the VP alone. So Kiss Pigs. Remember I said Kiss would automatically basically have a V, right? That is an interpretable, inherent V feature because it's a verb. But then the category keys needs a noun. And so in the from the numeration, it comes with a UN feature because it needs a noun in its derivation. And that UN says it's like an uninterpretable noun feature. So because of that, it merges with a noun, pigs. So pigs is a noun, and because it's a noun, it has an interpretable or inherent N feature. And so based on checking under sisterhood, of course, pigs is a sister to the verb, right? Kiss. And so what happened? Kiss looks to the sister and says, oh, good, my sister has what I need. And so the UN is checked, basically. That's how we build our structure. So what happened here is we did merging using feature checking. So we merge keys with pigs, but the underlying mechanism to derive that is by saying that keys, when it comes from the numeration, it actually comes with a UN feature. which says I need a noun. And so when it comes, so it's like, let's do it. So it says there is a keys. So it comes with, of course, its inherent V feature, but then it also comes with a UN. And so with this, of course, this cannot go to the LF yet. Remember that checking must take place, because if checking doesn't take place and then we delete this UN, the direction will crash. You see that now. So when it comes like this from the enumeration, what happens is that key says I need a noun. And so because of this uninterpretable UN feature, merge comes into play and says, okay, now I'm giving you a noun. And in the enumeration, looking at the enumeration, the noun that I have is pig. So I give you pig. And pig say, yay, good. I come with N because I am inherently a noun, right? So I have N feature. And so when that is the first process. So UN said I need this verb needs a noun, and then you merge it. But that doesn't end there, right? Because this UN is still there. It has to be checked. So even though now we've merged the pig, and so Kiss is happy that now I have a noun, and so I can check my UN feature because now my sister is a noun. And so now we are able to check the UN and we delete it. So when you check, you delete. That's why when you get to the LF, there is no crash of derivation because you have checked the UN feature. And of course, like we said, the head will determine the phrase. So this will be a VP because the head of this merging process, this two lexical item is keys, which is a verb. Okay, so that is how uninterpretable feature is checked basically. So what I've shown so far is just to show how we check uninterpretable feature by merge. All right, there's a question. Please go ahead, Dr. Jiboy. Go ahead with your question, please.
Does it just choose any noun?
Okay, good. No.
Does it just choose any noun at all?
No.
Or
No.
a noun that can actually collocate with the verb?
Yes. So no to the first question, yes to the second. Now, remember, I remember, I think was it that last or two classes ago, I spoke about numeration. That is a very important space. So in the numeration, so if you want to, so this is how it works, right? So your lexicon has everything, both the lexical category, the feature and everything, right? The functional and everything. Now, but we know that the lexicon is so large. It's a large aspect. But when we want to speak, as I'm speaking now, I'm using different sentences. And so which means that when you want to produce a sentence, there is like, in a way, you can call it an interface between the lexicon and the derivation itself, which is like the numeration. So numeration is like where you put all the things you need for that moment. So if you are going for camping, for example, maybe you are going for barbecue or camping, or you're going for vacation or whatever, you don't go with all your clothes, right? You pick in the box, you put the ones you need for that moment. That's how numeration works. So the lexicon is all the clothes you have, your house, your mind, your brain, language faculty. While the numeration is like the box that you're traveling back, where you put all the necessary item that you need for that vacation. And the vacation is now the derivation in syntax. So all that we need in the derivation at the point in the sentence, we take from the lexicon and we put it in that that intermediate position or domain, which is the numeration. Now it's in the numeration that now we can now begin to pick all that. So basically, in the numeration, pig is already there because we know that we want to construct a sentence, Adam kissed pig. So what we do is we go to our numeration, we pick the keys, and then we go back to the numeration because the keys has a UN feature. And when it goes back to the numeration, pig is already in the numeration. It's already in the numeration, right? And look at it. Even when you speak, except God forbid, I mean, except for someone who is maybe a mad person, right? A mad person, most times they don't no coordination between what they say. But someone who is saying already, you in a way you want to speak, you know what you want to say, you already have it. Even though you are producing non-finite, you can produce non-finite sentence based on the set of lexical items that you have. But in a way, each time you produce a sentence, you know what you want to say. Even though it can be spontaneous, right? But you know what you want to say. So that is what numeration does. So in numeration, you already have the pig. And so keys will not go if already you want to say Adam kiss pigs. Kids will not go to pig boy, because at that point it is pig that is in the context that you want to use, and that is already in the numeration. You see, so that is what happens. So you pick from what is already in numeration. So when you are on that vacation in maybe in Paris or wherever you want to go to, you don't go back home to pick that white cloth, because you already have a red cloth or whatever you have in the box that you want to use, and then you just pick from that box. You don't go back to the lexicon. I hope that helps. Okay, let's continue. So basically, what we've seen so far, what I've shown so far, is how merge works. But we know that the merge, based on this new, maybe not new for some of us, based on what I just introduced, the features, is like merge is derived by feature, basically. So you merge because there is a verb, for example, that needs a noun, and then you merge a noun, and then you delete or you check that interpretable noun, and you delete it because of the LF, so that you can have your full interpretation. All these have implication, actually, right? So if keys, for example, doesn't merge with a noun, the UN feature cannot be checked and deleted, and that violates the checking requirement in 16, right? And when that happens, it crash. It crash, because this must be checked, and when it's not checked, the derivation crashed. So there are other uninterpretable feature. Of course, it can even be a verb, it can be an adjective. Any category can be uninterpretable, and any category can also be interpretable. So if that feature is on a category that is inherently a verb or a noun, it is just interpretable. And then if you have another feature that is not inherent, that is not an inherent feature of that category or that item, then that feature is uninterpretable and it must be checked, basically. Okay, let's go further. We want to again see how we can trigger merge by feature checking. So we've seen a little of that in 20, or beginning from 18, right? We've seen how we trigger merge by feature checking, right? Because we want to check the UN, we merge the pig. Let's go even further. Right, I'm not going to go through 21. I already spoke about merge, how that it applies to two syntactic objects and the likes. And then we've also seen definition of a head, right? So a head is the syntactic object which selects in any merge operation, basically. So that's one way to realize or to know what the head is. So whatever is selecting the order is usually the head, and that projects to become the maximum category. So look at 2023. So in 23, of course, we have keys, which is the head, and it has an interpretable feature V. You can have UN, you can have another UN. And then, so imagine 23 as our numeration. Let's take this as our numeration, where in the numeration, we have the verb keys, we have the noun Peter, and we have another noun Mary. Both are noun now, right? So they have inherent N feature. While Peter is V, and in the structure we want to build now, we want to actually build a transitive. Let me see the chart. Oh, I thought, okay, maybe it's because of the fan. Is it better now? Can you hear me better now? Is it louder?
No,
Not
no,
yet?
it's not louder. Not yet, please.
What's going on? Do I now increase my... Can only increase my volume to hear you, but if I want to increase and make my audio more audible, I have to go to the settings. I don't know. Okay, so for some people it's loud and clear. So I don't know, maybe it's are you using earpiece?
No, I'm listening to you directly, and I'm at the topmost
Oh,
The
what
maximum
could
of
now
my
be the
volume.
okay, it's clear for some people. Okay, I'm going to speak louder. I mean, I can't shout more than this. Hopefully you can, maybe I can also come closer to the to my screen. Hopefully it can get better. And if it doesn't get better, maybe you log out and log in back. That can also be risky because of the network, but I hope you can hear me better. Okay, so yeah, let's assume 23 as the numeration. Yeah, so we have now the two nouns, Peter and Mary. We have keys, right, with this uninterpretable feature and then the V inherent feature, right? So what this numeration does says is that now we want to have a transitive verb, transitive construction where someone keys someone, right? So of course, when you say keys, we know that someone keys someone or someone keys something or something keys someone, whatever, right? So with this numeration, we can have a structure like 24. So how did we arrive here? Let's take it a step at a time. Now, don't worry about how everything looks. I'm going to take it one after the other. Now we merge keys. So we have keys. We pick keys from our numeration, right? This is our numeration, right? So this is not the lexicon. This is the numeration. So everything here was picked from the lexicon, and then we have the numeration. Now when we pick keys, because keys, remember, is a two-place predicate. We discussed that extensively last class, right? It's a two-place predicate, which means it needs an agent and a recipient or a team, whatever you want to call that, right? So, but it basically needs two arguments. And because of that, if it needs two arguments, two noun, that means it comes with two UN, basically. That's what keys come, it comes with from the numeration. And so it has to merge with two nouns. But remember that merge is binary. So we cannot say because keys comes with two UN, and then we now make it a ternary structure and say, okay, keys, welcome. Just we give you your two now, and then we are good to go. No, that is not what we want to do because merge is binary. So basically what we'll do is we'll first merge the first noun, which is Peter. And with Peter now, Peter is just one noun, so we are able to delete one of the feature, but we are still left with one, right? We are still left. And if we go to our LF like this, the derivation will still crash because remember, no uninterpretable feature will get to LF. When it gets to LF without being interpreted and deleted, the derivation crashes. And so even though we've checked one, there is still one remaining. And so we now I won't call that reprojection. It is not actually. What we did is we just move what we have here to the bar level, right? The V bar level, basically. And that is not a problem at all. Why? Because it is still a verb, right? Bar level, the head level is still a verb. So you can do this when you are drawing your tree. It is not a problem to take what you have here to this point because the V bar, it is still the verb, basically. So at this point, remember, we've checked the first UN with Peter, it has the N, right? There is now the second UN, and then merge says, I need another noun. And in this case, we merge the subject, Mary. And Mary is a noun, and then what happened? The second N is checked. And that is what we have here, right? So everything is checked. So Mary kissed Peter. So we have all our uninterpretable features checked. And of course, we are good. Of course, we know that from the VP, there are other things that can be, that will come up like maybe the TP, IP, and everything. But at this point, basically what we've shown is that we've been able to derive our merge by, feature checking. And all the features have been checked, basically. Okay, so this also predicts that we cannot have a structure in which A merges with B and A being the head, while B still has its own C selectional features unchecked. You know what this means? This means that when you have a structure like 24 and Keys and Peter comes in, it is risky, or not even risky, it is not possible to have a case where Peter comes with its own unchecked, uninterpretable feature. Take note. let me use 25 to explain what I just said. When we merge Y and Z, the UZ on Y is checked by this Z, right? But Z has its own UW that has not been checked. And when we go with our process by now merging a W, this derivation will crash. Why? Because we are still left with an uninterpretable unchecked feature, which is not allowed. So it means that before we even merge this Z to the Y, it must have already been checked. Probably we can assume that there is already a merging process that has taken place where there is a Z with a U with a UW, right? And there is already a W here. So basically with a W feature, let's say a noun with W feature. So something must have happened where we are able to now check this before it gets to this point. So if this has not happened, this process that I just give here, if it does not happen, and then we just merge a Z or an item with its own unchecked, uninterpretable feature, then our derivation will crash as we continue. Because remember, we can only merge at the roots. We can merge at the root. So the moment you merge Y and Z, and then we are able to check the UZ on Y, and it gives us a new syntactic object. When we want to merge again, we can only merge at this root. That's why we can merge only W, and then W merges with X, and then it gives us a new syntactic object U. And because of this, remember, we check based on sisterhood. All these guys that we are merging at the top are no longer sister of UW, so it cannot be checked. Which means by the time we get to, by the time with our derivation and we want to send it to the LF, it will crash because there is an unchecked feature. And this is not just abstract. This is not an abstract something. We can see that in languages. Let's look at 27. So what we just saw now, the fact that we cannot have an unchecked, uninterpretable feature merging with another unchecked, uninterpretable feature, that fact can be seen when we look at examples like 27, A and B. So look at 27A. So Julie became fond. That's not fine. It has to be Julie became fond of Lloyd, or Julie became fond of someone. Julie became fond of Sam. I don't know if Julie is the name of Sam's wife. I'm not sure. I don't think so. But you know what I'm talking about. So Julie became fond. It's not fine. It's not possible, right? And why is that so? That is because this will give us a structure like 26, where, let me clean all these things I showed here. So assuming that nothing is beneath Z, it means that Z has nothing, and then this UW cannot be checked as we continue our derivation, right? That's what that will show. So look at 28. Let's use 28. In 28, became fond of Lloyd. This is fine because there is, so the UP is checked because we first merged, the prepositional phrase with fond, and then the UP on fond is checked by that P. Now contrast that with 29. In 29, if you have a structure like this where you have became fond, even though you have of Lloyd rather, this is ungrammatical. Why? Who can tell me? I've said this already. Anyone can help us? Why is this still ungrammatical? Because even though we still have of Lloyd here, the derivation is still going to crash. Why is that so? Anyone?
Because
Okay.
fund is not the same.
Again?
Because fund and of Lloyd are not sisters.
Good. Thank you. Thank you very much. That is it. So even though Lloyd is here, of Lloyd is the sister to the V and not to fond. Remember, fond is an adjective phrase. And you remember our structure is built hierarchically and is binary. So if we already build, because what this structure in 29 shows is that we build this separately and then we merge it with P. That's what this shows. It doesn't show that fund is merged with P. No, it shows that fund is merged with V. And when it's merged with V, V is happy because V has a UA. Remember, V has a UA. U, that is uninterpretable adjective feature. And so when V merges with with fund, it's fine. It gets deleted. But fund on its own also has a UP. And in this position, it can no longer be checked because Lloyd is not a sister, which means we have to bring Lloyd beneath it. And that is what we have here, right? So this is the best structure, which means we merge fund with the prepositional phrase first. And then the UP, because this is a prepositional phrase, of course, it has inherent P. And so the UP is checked. And then we continue with our construction. We merge became, and then became comes with a UA, that is an uninterpretable adjective phrase. And then this whole new object that is realized or that is derived based on the merging of fund and of Lloyd is, of course, inherently an adjective phrase. So it has it has an A feature. And then that A feature checks this UA, and then this UA it can be deleted, and we can have our transfer, interpretation at LF, no crash. But this crashed because we have a case where this UP is unchecked. In fact, if we want to have a structure for 27A, 27B, these two structures here just shows the different way of having 27B, but we know that 29 is bad for that because we can't check UP. But if we want to have, Julie became fond, which is itself ungrammatical, it will be a case where we just have, just a V and then the became. So just this one, this just let me use this, just this structure alone, basically, just this structure. And in that case, this UP cannot be checked either ways because there is nothing. The sister of fun is a V and not a P, so it cannot became, even though, the prediction of this merge is that if became is a P, it should be able to help its sister and just check the UP. And the same, so it's just like give me, I give you, right? So the became will get the UA, the A from fund, and then fund will get the UP from became. But we know became is not a preposition, it's a verb. So either way, the derivation crashed. All right, let me see the chart. The question. Yeah, good question. So the question is, are these features on the lexical items or on the phrases? Of course, they are on the lexical item, that is the head, but remember we say the head projects to the phrase. So whatever your head has, you have it, basically. Again, let me make this let's do this. I always like to bring examples that will make us to remember. Remember earlier I used husband and wife. Now look at your head, like your physical head, right? Your head is part of your body. So your body is the phrase, but your head is part of your body. So whatever you have in your head, the whole you has it. So even though the head has the V, the whole phrase is a V because that's an inherent V. And that's why we are able to look at what we did here in 24. Remember that even though the head of the VP is where you have, all the feature, but these features can be projected to bar level and even to the phrasal level. Nothing changes, nothing. In fact, it's not a problem at all because VP is still a verb, basically. So the head of Daniel is still Daniel. And that's why when you are doing your passport, they don't want all your body. They only want your head. That's your identity, even though the whole you is you, right? So, all right. Any question before we continue? So what we've seen so far basically is the fact that in building your structure, we need feature. And even though we need feature, those features must be checked based on certain requirements like the sisterhood requirement, basically. Okay. Yeah, the similar thing you find. So what I just explained now, you can see that in 31 and 32, right? So in 31, you have the sentence, I'm collecting letters to Peter, right? So letters to Peter is our concern here. So to Peter, of course, we first merge and Peter, and to is a preposition, but then it has a un, and then when you merge the noun, it's fine because this is a noun. So it checks the un, and we can delete this un, and then we continue our derivation. Now we merge letters, and letters is a noun and the plural, but then it has an uninterpretable up, right? Which is interpretable provisional phrase, provisional feature. And then when you merge this P already has a P, right? PP is already, it has an inherent P. And then because of that P, we can check the UP on letters and then again delete. So when you check, you delete basically. So checking is synonymous to being, deleting a feature. So you cannot delete a feature without checking that feature, basically. And when you check a feature, you delete the feature. Okay, again, that what I just said now is is controversial because there are discussions on that too. There are discussions that have shown, or that have, people have argued that you don't have to even check certain features. That's just another area. You don't have to check certain features, and certain features that are checked don't have to even be deleted. So there are many. So when Chomsky started this feature checking and everything approach, and it gained a lot of prominence or even attraction in his 2000 paper, Derivation by Phrase, and also 2001 paper. A lot of things were discussed with feature, but subsequently people have argued that feature checking is not, can be how do I? It can become simplified. That's what I'm looking for. Can be simplified, where you don't need to delete a feature before you can still interpret it. Okay, so the idea of merge only applies at the root, right? We've discussed that already. So the idea that merge only applies at the root is theoretically significant, and it receives empirical support. And I've been discussing extension at the root, and this is what that condition says. So when you are extending your merge at the root, this is called the extension condition. So it's a condition that a syntactic derivation can only be continued, or can only be extended by applying operations to the roots of the tree, basically. So what this simply means is what I gave here. So syntactic derivations cannot go back and add something inside the tree that has already been built. Right. So let me give a quick structure to show what I just said. So if you have a structure like let's say you have built your structure VP. Why? So if you build your structure, let's start from the bottom that way. So what I want to explain now is the extension condition. So in case you're wondering, I want to explain the extension condition. So if you, I think I can even use 20. So let me use 32. So look at this structure. We build it from the bottom, right? So assuming this level, this P. So you bring in 2 and Peter, and then it gives you P, right? Now, if you want to extend this tree, you extend it from the root. This is the root, the P, and then you bring a new derivation. Now, what the extension condition says is that when you are building your structure like that and it goes up, you cannot come back, let's say after you get to a VP, and then you come back and say, oh, I forgot, I need to add something. Let me add something here. No, you can't do that. That's what extension condition says, that a syntactic derivation cannot go back and add something inside the tree that has already been built. So after building P, and then you build NP, you build VP, or even to this NP alone, and then you want to come back and put something here, you want to add in something here, that's not possible. Extension condition kicks against that. And there is one area where this becomes controversial. I'll just mention it. I'm not going to go into deep, and that is with lowering. When you are doing movement with lowering. And that is this is one of the reasons why lowering was banned, like syntactic lowering. So there is like a ban on syntactic lowering, where when you are building your structure, if you are having movement, you prefer to move upward than downward, like lowering what you have built already, bringing it into, what you have already built. So 2 ways is that there won't be any position for you to occupy, and if there is a position for you to occupy, people still frown at lowering or downward movement, so to say. It doesn't mean there is no downward movement. People still do that, but it is not really an acceptable thing in the syntactic field, in the field, right? Just like downward agree. Downward agree, people do that. People do that a lot, but yeah, there is a lot of controversy on that, whether you agree downward or upward. So all we have been even doing here with this checking of feature and everything is basically agreement. So what we just did is that there is a feature on the T, and then this T is a probe, right? And then it probes. That is, it searches. That's what probe means. It searches, and then it finds that the sister has the feature it needs, and then it agrees with it. And that feature and that sister that has the interpretable feature is the goal. Remember, I spoke about probe and goal earlier. So the item that needs to be interpreted, that needs an interpretable feature, is the probe, while the item that has the interpretable feature is the goal. And then probing is just the mechanism, like the searching mechanism. Okay, so that is the extension condition. It says you have to extend at the root, and when you have done that, you cannot, whatever you have built up there, you cannot go back to add anything inside what you have already built. That is the extension condition. But look at this, what I gave you. I just gave this in case you want to maybe research more, or you want to know more about this extension condition. Even though it is a condition that is usually obeyed in syntax, but there have been some syntactic phenomenon that in a way they violate the extension condition, like tucking in, like sideward movements and right on raising, for example. This kind of constructions, they violate extension condition. Let me talk about tucking in, and then we'll move on. So we're tucking in. So tucking in is basically if you have a construction like okay, I even have, no, I don't have a structure. I thought I had a structure. So if you have a structure, so usually so Novin Richard from MIT, he proposed this tucking in approach to WH, multiple WH. That's one of the motivation for tucking in multiple WH. And what does that mean? It means, for example, if you have, this is not a big space, but I will see if I can just make a little tree to show that. So assuming you have your, so in Bulgarian, they use more of Bulgarian and many other languages that allowed multiple WH fronting. So hypothetically now, I'm giving this in English. English does not allow multiple WH fronting, but in Bulgarian it does. So whatever you see here, even though I write it in English, is a Bulgarian example. I don't remember the Bulgarian example, but this is just the Bulgarian example. I'm using English basically. So if you have something like woo, let me not lose you. I want to just give you a brief, what's it called, talking in what that means in regards to violation of extension condition. So who, what, so we want to say Sam saw Adam, or Adam saw Sam, and then you want to say who, what, saw. That is who saw what, or who saw, yeah, Sam saw the boy. No, Sam saw the dog, for example. Sam saw the dog, and then you want to make both Sam and the dog a WH, and then you say who, what, saw, or who saw what. English you say who saw what, right? But in Bulgarian, it's possible to say, or in some languages that allow multiple WH fronting, you can actually say who, what, saw. And that this is very interesting. Why? I will show you why. Because if you have a structure like a CP, So what talking in does is that, remember that usually the CPU would have a one specifier, but now we have multiple. And how do you know it's multiple WH fronting? We know it because the language, if the language is SVO, the subject originates from here and the object is here. And the fact that who now is now in this position and the WH word object is now here, that is already an evidence for multiple movements. If it is what, for example, if we have what who saw, this is debatable, right? So if you say, if you have, what who saw in a language that is SVO, like Igbo or Yoruba, this is possible, right? You will say kini tani ri, isn't it? So kini tani ri. Now, in English, for example, what who saw, of course, this is not possible to say, but in a language that allows this, why this is not as easy compared to this is that we can say this is just in situ, right? This is doesn't move. It's just in its subject position because nothing really is showing that it has moved. But with this one, there is evidence that there is movement of the subject because there is already what in between the position of the canonical subject here and this position. You see what I mean? So in this case, people usually assume vacuous movement, that there is movement, but it's just vacuous. You can't see it. Why some say there is no movement. It's just in situ. In situ means it is in its um original position after you have the case checking and whatever checking you want to do. Right? Now, forget about this structure. I just brought this in. What I'm going to show is this structure in who, what, saw. Now, if you have this, we can have double bar level. And then you have your TP and everything. I'm not going to draw the TP, so I just assume there is something like this. This is where the talking in comes in. Now, with talking in, what happened is that it assumes, remember, locality, even with agreement with locality. If your C agrees, it will agree to whatever is closest to it, right? When we discussed locality already. If you want to move something, you move the closest thing. And what is closest here will be the subject. So who will be here? Saw. And then what is in the object position, right? So the closest here is this, right? Which actually you move. Okay, let me do this. If I do that, okay, because I want to. So you move. So when you move, it's assumed that you move here to this position. Now, at that point, this C bar level is not available. I draw the finished tree, but if I'm going to do it step by step, this C bar is not yet available. This one here is not yet available. So when you move woo to the spec of the C, the CP, now what talking in does is that because what is not above woo is below it, then you talk in. That is where that word comes from. Talk in. That is like you talk inside. Now, let's relate this to extension condition. Remember our extension condition says merge extends at the root. So you would assume that this WH, the word, should move to the root here because CP is the root. But instead, it moves inside the CP. That is a violation of the extension condition. But it's allowed in languages like this that allow multiple WH phrases like this type here. And that is called talking in. So you talk in the WH object inside the CP, even though you have already moved woo first. You move woo to the spec of CP, and the prediction of extension condition is that you should move WH object to the root of the CP. But because that is not what we have, what we have is not what who saw. We have who saw what. Then you're talking. Basically, you're talking. You create another specifier inside what you have already built. That's a violation of the extension condition. Is that clear enough? So if you want to know more about that, you can read. There is a reference for this. Richard is a whole book, but then he has some articles that talks about talking. You can just start talking in on Google Scholar, and then you see that. All right. So That is that for extension condition, merge, and the properties of merge, feature checking, trigger and everything. That is it about that. Any question before I continue? Any quick question? Anyone wants to ask a question? Any question? Maybe you want a clarification about something? Nobody? Okay. All right. This chapter, this section, I'm not going to go through it. This motivation of a little VP, I just put it there because I'm going to you begin to see little VP now. But I remember someone asked during the last class about the little VP, and I spoke about causative as one of the motivation, right? So that's why I included this section. In case you want to know more about the motivation of the little VP above the big VP, please go through this section 4. It's very explanatory. You will enjoy it. So go through that. You will see. Yeah. But in the next session, I'm going to use little VP for my discussion. Okay, you have a question, Doc? Please go ahead. Dr. Ebikunle, go ahead with your question, please.
Thank you. Sorry, I'm just joining. What then is the relevance of the intermediate the intermediate
Projection.
complementary one where you have C bar, you have like 2 of them. I don't know if X bar is still allowed in MP. So because I can see C bar 1 and C bar 2 in the last 3 that you just draw. And nothing is occupying the lower one.
Which lower
the
one?
C of the lower one. Yeah, exactly.
This
So
one?
what then is the essence of that C1?
Okay.
C bar, the C bar. We have like 2 of them between CP and TP.
So I just use this to explain the talking in and multiple WH, right?
Okay.
But to answer your question of C bar, right? So C level, usually, the motivation for C level in minimalist program is for merge. So when you have to merge a complement and you have to merge and another argument, then you need a C bar level. So for example, look at this structure in where I gave the whole sentence of the VP. Where was that? So yeah, look at this. This is a bit rough. Let me clean it a little. So look at this structure in 24, right? So in 24, you see the C bar level of the V, even though I didn't include it there, but it's actually, you can have a C bar level, a bar level, not C bar, a bar level here, right? Now, what happens is that if you, when you're drawing your structure, so usually you need the bar level for, when you have another argument that is part of, that head. So Kiss as Mary, it's like a true place predicate. It needs both Mary and Peter, basically, right? And so if we don't need, if we are not going to merge another argument, then we don't need the bar level. We are good by just saying a VP, right? And then just the V, and then the NP, like something like slap the boy, right?
Yeah.
Slap the boy, like imperatives, for example. So with this case, you don't need any bar level because nothing, no. So with MP, I'm going to talk about the principle of economy. I'm going to talk about that. That's one of the, I think the last section that I'm going to talk about now, right? So principle of economy says you have to be even your derivation, economy plays a role. So if you don't need the bar level, take it out. Unlike the S-bar theory, like I said earlier, it's redundant. Even when you don't need the bar level, you still have it there. So and I noticed that with many papers, many papers still use, even though they claim they are using MP as their framework, they still use the bar level even when you don't need it. So for example, you have NP, and this MP doesn't take any complement or even take any, anything. It just N, like the boy, or it's just Sam. And some people still, go with, or what the X bar level will do is that you still have the bar level, and then you have the N, and then you now bring Sam. This is what typical X bar theory will do. Yeah, will always be this bar level, right? But in the minimalist program, you only there is the principle of economy. If you don't need this, you take it out. So if we have just Sam, you don't need all those. You just say Sam is just an NP. Why? Because it's a noun and the head projects to the phrase, and that's good. We are good to go. We don't, in fact, if you like, you don't need to even bring this N there. We know it's an NP. An individual is an NP in semantics, right? An individual, NP, and the like. So the bar level, now coming to the CP, this double bar level here, it's just because I wanted to discuss multiple WH movement. If it is a single WH movement, we don't need two bar level, of course. It's just one bar level. And I use this to explain talking in. So I don't know. I don't know if you met my discussion or explanation when I was discussing talking in. That was why I added it. So it's not something that you see. It's not a common it's not a common sight, basically. You need to be one bar level, and then this C would have the, like in our languages, right? So in Yoruba, you say Bola ne. So the ne would be on this C, or you can use the focus phrase if you want, the split CP, right? So if you want to go with the split CP of Rizzi hypothesis, then it will be a focus phrase, and then the head of the focus would have the focus morpheme or focus marker. But if you want to still maintain CP, you can put the head of the focus of that, the focus marker rather, in the head of the C, basically. Does that explain? Does that answer your question, Doc?
Yeah. It answers
Okay.
it. Yeah.
All right, thank you. So yeah, like I said, you can go through the section on four to see the motivation for little VP. I'm not going to go through it, unfortunately, because of our time. All right, so let's look at principle of economy, right? So we've looked at the principle of full interpretation, which says anything you have in your structure must play a role. There is no place for superfluous element, whether it is lexical category or even feature. When it is a feature that is superfluous, that means it is uninterpretable and when it is not interpreted, when it gets to LF, it crashed. If it is an item, maybe a lexical category that is in the structure, when it gets to LF, if it doesn't have any function it's playing, it still crashed. So there is the principle of full interpretation. Now I want to look at another principle, which is economy. Again, I'm going to tie this to what we started with about minimalism. Remember that with minimalism, we are saying that we want to be able to link what is happening in the language faculty to the general cognitive ability of humans, right? So the full interpretation, we know that a normal human would want to be superfluous. And the same thing, normal, I'm using normal because it's possible to find, different kind of people, right? But we know that normally you want to observe economy. You want to be economic. For example, even in your speech, you want to be as precise as possible. So these are basically principle of economy is basically what we use every day. If you want to put Maggi in the soup, and you know that this soup needs just 2 Maggi, you don't put 10. You put 2, you put 1, right? You want to put salt, you don't put the whole spoon, except if you are doing an occasion. So basically, you see that the cognitive ability of humans, what we are able to do, what we know, our capacity, we can now extend it to language faculty itself, which is economy now. And what economy does in language faculty is that anything that is done, with least effort is preferred over what is done otherwise, right? So this is just the natural way of doing things. For instance, look at this phonological assimilation rule that we have in 53. So in 53, we know that 10 ends with this phonetic symbol with N, right? With N. But then if you have papers following it, it becomes this N is phonetically realized as right? Now, what happened here is we can link this to the principle of economy, right? Because even though we know that this this N is still, but due to assimilation, it assimilates to, this is like homogenic assimilation, right? So it assimilates to the labia position of this P, and then it realizes the labia of, this alveoli is no longer N, but now the labia counterpart. So you have 10 papers. So if you pronounce 10 papers is not, except you do it in slow speech. That's when you say 10 papers, right? But in fast speech, it's just 10 papers. 10 papers, not 10 papers. It's like 10 papers. 10 papers, right? So you have an assimilation here, and that is due to the P. So what we see here is like, and you know, we can link this to the principle of economy, because we know that in our articulatory organ, it is easier to move to the closest than to move from one point, you know, to another point that is farther away. So the closest, because if you have 10 and p is in the bilabia, the right, is with the alveolar. But then this actually has a counterpart that is also bilabia. So it says, if you bring this, you know, this as principle of economy notion into play here, what we see here is that when it comes in contact, this comes in contact with, you know, a bilabia, then it says, instead of going back to the alveoli and pronouncing let me just, I have, you know, a counterpart which is so just have it as 10 papers. So basically, and that is how the, you know, the articulatory organs also work. So in a way, it's easier to, when you are doing your articulation, to pronounce what you have at that point, rather than going backward to pronounce, you know, what you can do based on economy, what you can do easily, basically. So instead of saying 10 papers, just say 10 papers, right? 10 papers, 10 papers, basically. So that is principle of economy at play in just using phonological concept to explain that. But in syntax, we also see similar principle, you know, of economy that is at play in many constructions. For example, with WH movement in 54 rather, right? In 54, if you have a construction like 54A, Adam thinks Sam saw a monkey. The principle of economy says that even though 54B is what you would have, so you say, what does Adam think Sam saw, right? Or you can say 54C, who does Adam think saw monkey? Or who does Adam think saw what? But 54E is ungrammatical, and we can explain that based on, you know, the principle of economy. So what does Adam think who saw? We are going to explain that with economy. What does that mean? It means when you want to move, if you have your C, look at 50, let me 55 now. That's the structure, the ungrammatical structure. Now, if you have your C, and assume that your C has a UWH feature, that means it's saying I need a WH feature to move to my specifier position. And so remember our probe. So which means this is the probe. So the probe usually is what has the uninterpretable feature or unvalid feature, whatever. So this probe, when it probes down, it meets this guy. It meets the subject WH before it meets the embedded object WH, basically. That's what this shows. So look at this. You have two WH phrases. You have who and you have what originating from this position. They are both merged in this position, right? Now, when you want to agree, your WH feature, when it searches down, the first one it meets is this one before it meets this one. Don't worry about this guy. This guy is just an intermediate step. It's just an intermediate step. So forget about this for now. So when it probes, at that probing point, it come in contact first with this before this. So basically, this one is closer. Oh no, this is serious. Yeah, so the subject WH phrase is closer to the C that is probing than the object. The subject is closer than the object, right? Hierarchically. Because when it probes, it meets with the subject first before meeting with the object. So that is why 54D is fine, right? So who does Adam think saw what? So that is fine, because when it probes, economy says you take whatewer is closest. That is economy, right? The closest one is more economic than, it's like when you are traveling and you want to, maybe your tire is flat and sometimes you need a new pair, or you want to work on your tire, and there is a organizer just at your front, but you say, okay, I don't want to use this one, I want to go to the next person. That is not economic. In fact, that might lead to a lot of things happening to your car because the tire is already flat. So you rather go with the closest one. That's what is going on here. So this WH phrase, when it comes here, it meets this closest, and then of course it triggers the movement of this wool to this position. That's what you have in 54B and 54D. Who does Adam think? So the C, it probes, and then it gets to here, and then it takes WH. But in 54E, the problem is now what that is now the structure in 55, where the WH probes, and then it sees the who, but it jumps it. It goes for the second WH phrase, which is in the object position, and then it triggers the movement of this to this position. So it triggers this what to move to this position. And when it does that, we have an ungrammatical sentence. So what does Adam think who saw? What does Adam think who saw? That is not fine based on the principle of economy. So the closest should be the one moving here, not the one that is farther away. That is one. That is one issue. Another issue with this is that, remember, you know that we already say that movement is in phases. Like it doesn't move at once. It moves to intermediate position. So if we have this intermediate position, we can assume that this who has moved to this intermediate position. And when it moves to this intermediate position, or to this position rather, it can constitute a barrier for whatever is moving. So this will not be a position that is available. That is another way to look at it, right? But what I want you to pick from this is just the fact that with the principle of economy, it says when you are moving to the spec of the C, you move the closest WH. And the closest here between this WH1 and WH2, of course, is this one, right? So this WH1, that is the subject WH, is closer to this probing element, to this one, this WH2, which is the object WH that is farther away. That is the principle of economy. So you move the closest rather than the farther, the one that is farther away, basically. So we can also see the principle of economy in operation when you see when you look at auxiliary inversion, or aux to C movement in yes or no question. Look at 56. So 56, you say Adam should have gotten the price. That is our canonical sentence. But if you want to have it as yes or no question, it will be should Adam have gotten the price, and not as Adam should gotten the price. Why? Who can help us to explain this? Why is C ungrammatical? Compare 56C with 56B. Why is 56B grammatical and 56C ungrammatical? Remember, both should and have are both auxiliary. So why is the movement of should to the initial position fine? Why the movement of have to the initial position bad? Anyone want to help us with that? Why is that so?
Because should is closer to Adam than have. So the principle of economy states that the closest has to move first.
Yes, exactly. That's exactly the point. Thank you very much. So that's the principle of economy. So you move the closest. And so when you are moving, and in case you want, do I have a structure? Ah, good, I have a structure. So basically what you have is that there is should here. So let me see if I can have both. Yeah, so I want to have 60, 56, and 57. So now in 56B, if you move should, of course, look at this structure here. Even though this structure in 57 is that of 56C, but I can also use it to explain 56B. So should in 56B is the one moving to C, right? So you have should Adam have gotten the price. So you are moving the closest to C. That's what you have in 56 B. But 56C, you are jumping. So even though there is a potential candidate for movement that is closer to C, you jumped it and then you go for, or you went for the one that is farther away. That is against the principle of economy when it comes to derivation or even locality with agreement, right? So that is why we use this to explain the ungrammaticality of 56C. Whether you have or as, it doesn't matter. So Adam should, it doesn't even possible. So as Adam should go to the right is also not possible. And that is because economy says you move the closest to C, similar to what we found with W8, right? So with W8 also, you move the closest W8 to C, to spec C in this case, because the C is already occupied. So we use the spec C for W8 phrases. That is why 54D is fine. Who does Adam think? This who here is from this position and is closest to this position compared to this one that is farther away. Principle of economy. So these are just few instances where economy, comes in that principle. There are many other instances. Agreement is a very big, very large area in syntax where we always use principle of economy with respect to, the closest agree. You agree with whatever that is closest, that has, the required feature that you need. All right, any question based with respect to the principle of economy before I move to phases, and this will be the last section, and it's a very short one. Any question so far? Okay, there's a question on the chat. Are the rules of external and internal made different? Because here, instead of the whole root, some parts of the root are moved or internal. Which one do you mean? Which part are you talking about? If you can highlight that, which part are you talking about? But I can answer the first question you already have, which is, are the rules of external and internal merge different? So it depends on the way you what you want to describe. But literally, yes, of course. And but the mechanism that we've been looking at. So if you look at merge, remember I said there is internal merge, which is you are merging two objects together, right? And then there's also external merge. So the underlying principle, the underlying trigger is the same, which is feature. Basically, feature is the underlying trigger of whether internal merge or external merge. That is the same across board. Feature in minimalist syntax, right? So that means you merge. You remember what we saw already, right? So whenever you want to merge, you merge. For example, you merge the noun with keys because there is a feature, an uninterpretable feature on keys. And so that triggers the merging of a noun because it needs a noun for this UN to be checked. So that is one, and that is for internal merge because you are bringing, sorry, that is for external merge, rather. You are bringing two.
Should I be like embarrassed girl in front of my husband? Like, you don't want to do. Maybe the husband not gonna like the girl. He never see girl walk like that man.
Please mute yourself, please. Yeah, thank you. Not embarrass yourself. All right. So, keys, both keys and Peter are both, external merge. They are merged from the numeration. But then the trigger for that merge is feature. Now, internal merge is what I just explained now with movement. That is internal merge, right? Where let me use the short, this tree, where you merge, even though should or have is already in the structure, but now you internally merge it. That is, you move it from this position to this position, and there is still a feature for that. So both internal and external merge are feature triggered, and the feature for this one will be UX. There's a uninterpretable auxiliary feature that needs to be checked here. It can be UX, or you can, if you want to make it more, what's it called? You can use UQ, that is as a question. So you can also be UQ. You want to have a question because we are looking at a yes or no question in this case, right? So, but what answering your question is the question. The answer to your question is that both internal merge and external merge they are both triggered by feature. So feature checking and agreement triggers them, right? Both of them. The let me see. I have okay. All right. So I'm just going to stop there. I'll stop with that. So there's a question from Dr. Ibikunle. I'll take that question and let's round off.
Yeah,
Please go ahead.
thank you so much. Quickly, let's see that tree in 57. I
57.
mean, that tree diagram in 57.
Okay.
Do you want to bring it down a bit?
Yes.
Okay.
57.
Yeah.
This one.
Exactly. This tree. Now, you've been able to convince us why it's not grammatical to have when have move instead of should. And,
Yeah.
I could see that should and have seems to like be helping verbs. I mean, they are helping verbs in that construction where you have Adam should have gotten the prize. So should have there seems to be auxiliary helping gone or so. So I'm kind of wondering from this tree, how do I know that should rather move instead of have? Because on the tree they are not occupying similar node. Let me just put it that way.
Like similar position, like the same position.
Like we have for the WH the other time, where the both of them are occupying similar node CC. So I'm wondering how do I know that should rather move, because should is occupying T node, while I can see have on the ox node.
Yeah. So the answer to your question is what you said earlier, right? Is you know what we move based on what is the closest to C.
Exactly.
So the closest to C between should and have is should. So should move. And that's the principle of economy, right? You move the closest to the landing position. And if we do otherwise, so when you do that, when you do the movement of the closest, 56B is fine, right? Should Adam have gotten the price? So the closest move, fine. But if we do otherwise by moving the one that is further away, that is not the closest, you move up, then we have ungrammaticality. So you know what to move based on closest, the closest item, and that's the principle of economy. That's basically what you do. So, and this cut across many derivations, not just with this yes or no WH question, even with head movement also. So usually you move what is closest, and there are many ways to go about that in case you find, and in fact, when you look at many of these morphological, so I want to talk about head movement now. When you look about many of these morphological, rich languages, the way they have their inflections in the verbal frame is usually consistent. It's usually symmetric in a way. It's not something that you just do anyhow. In fact, those kind of categorizations or frame have been used to argue for the kind of projections that you have in the V periphery, so to say, right? Because they are in a way systematic. When you have auxiliary above, like perfective rather above progressive, and then above the perfective you have the T and everything. So there are morphological evidence that shows that, and with respect to movement, you usually move the closest, basically.
So is it bad for me to have on that tree? Is it bad for me to have another T bar instead of having OXP? Can I have another T bar so that have will be under the node T like should? Is that bad?
Yes, it is bad. And it's bad because it's bad because should is so again I have okay, how do I now when you have bar level, you do that when it is very necessary, if there is no other position. But have already has a position. So you are saying that why not have double T bar level, right? Now the motivation for that is not clear. There is no motivation for that except for the fact that you don't want to use OXP. But if we want to, we want to be as explicit as possible, then why do we need to merge, have in another bar level? The bar level that I had earlier with C bar, remember, is because we want to do internal merge. We need two positions. We need positions for the the 2WH movement, multiple W. There is a motivation for that. There is a derivation, there is a structure that necessitates that. But in this case, there is already, we can already have a position where the half we occupy. We don't need to assume, double bar level. And there are other arguments that shows this, what's it called, as well, right? So for example, in there are languages where you actually have different movements of aux, like auxiliary, would move to the T, whereby you have, let's say there is, hypothetically again, let's say this is, even though this looks like English, but let's say this is just a past tense. And then there are languages where you have to move the auxiliary from the low position. So this is in the T. You move it from the low position, and then it merges with the T. And that is already motivation that the auxiliary has to be somewhere lower. It's somewhere. It's not in the T. It just moves. That is like have, for example, it moves to attach to, whatever is in the head of T. And usually T is the head of, is where you have the tense, right? That's where you have the tense, basically. But should, so there are categories that can be in the tense, like should, like the infinitive to as well, like the do support, the do, or even the ed that we know in English. So these are categories that can be in T. But with have, with as, with ing, like progressive, all those are under the aux-p. And this aux-p can be split into, you can have aux-p, which is the perfective or the progressive. All right, I'm going to end now. My time is up. I'm going to just conclude. So what we've seen so far, sorry, I can't go through the phase because of the time. You can go through that, but I will encourage you to actually go through that section of the motivation for little VP for those who want to know why the little VP is motivated, right? So what we've seen so far, I'm just going to conclude with these 3 points, is that the development in generative model or grammar itself has been an interesting enterprise, right? So we've seen different development from one state to the other. We've seen the abandonment of different notions, the refinement of some notions. But the last one, that is the current program, minimalist program, is called a program because it's still being developed. And this is interesting because it's been since 1995, it was said that it's still being developed till now. I don't know when it will finish developing. It's still being developed, and a lot is going on. A lot of ideas, a lot of arguments here and there. But the most important thing is that the minimalist program, the aim is this, what I have summarized there. The aim is basically to explain linguistic phenomena from external cognitive abilities that is apart from the language faculty itself. So we want to be able to, link the language faculty to other cognitive abilities like economy, full interpretation, and the merge, and many of the notions that we have seen so far. So that is the end of this long class on from traditional grammar to minimalist syntax. And thank you very much for the very interesting questions, many contributions. Thank you. That's been very interesting having you guys around with many of these questions. Thank you. I'm going to stop the share and see if there's any quick question. Oh, I'm sorry, I can't explain face edges. You can go through the handout. It's very accessible, I assure you. Yeah. Yeah, I'm going to. I can drop the handout of last one.
Thank you so very much. That was really explosive. When they say something is explosive. Yeah. Thank you so much for the classes. Thank you for the lecture. It's very interesting. Showing me how syntax is very, very interesting too.
Yeah.
Thank you so very much. So we want to end now. And we'll converge in 30 minutes again. So let me stop recording.